Again, we can use the numerical optimization of PyTorch instead of our closed form solution from Wienerhoff and a convolution layer. So we can use the mean squared error as a minimization criterion or the loss function. And in this case, it does not differ from the target of the closed form formulation, and hence we obtain very approximate solution. So here the desired target signal Y is the audio input X, but one sample in the future. So we're doing here importing PyTorch. We're using a librosa to load audios, matplotlib plot. Here we are defining our filter length. Here we're using dilatations, upsampling the filter impulse response. The new filter length will be L minus 1 times dilatation plus 1. Here's a function to convert a vector like a mono audio signal into the shape that PyTorch expects. Here we are defining our model. We have a convolutional layer, one input channel, one output channel, kernel size equals to L, stride equals 1, and the dilatation equals to the dilatation that we define here is equals to 1, and the padding is the dilatation times L minus 1. We are not using any bias. And here we define our forward function. So then we are loading Iron Maiden, Aces High, do some normalization, and we have here the audio signal to predict. So
we shall go on to the end.
Once again,
we shall fight in front.
Is the Aces High introduction speech. Now we are defining our loss function, which is the mean squared error, and here we are using the Adam optimizer, and we start training our model. And this here is the result. So we have here the original and the predicted signals. We have the original and the prediction error, and here we have the weights, and we see that it's very similar to what we obtained using the Wienerhoff closed form solution. Here we have.
We shall go on to the end. We shall fight in France. We shall fight on the seas and oceans. We shall fight.
Predicted signal.